Okay, let's go over the review sheet 1-4R. So the first problem is if M is the midpoint of segment AB, which statement is false? So the first thing we should do is draw a segment AB, okay, and put an M in the middle, and make up some numbers. That'll help us tremendously if we try to understand this. So let's make up a nice easy number 4 and 4. Remember, if M is the midpoint, that means that AM equals MB, right? Which is right here, so you know that this one is true, okay? 4 equals 4. Let's try this one, put some numbers in, right? So let's use our numbers that we just made up. So AM, the distance between A and M, is 4. AB is 8. And they're saying that equals 4. So you can see right away that 12 doesn't equal 12. So this is the false statement, okay? Here, if we try this one, just in case we try this one first, it's 8 minus 4 equals 4. That's correct. That checks out. And 8 divided by 2 equals 4. That checks out. Okay, so the answer is 3. Okay, problem 2 is a little bit tricky because P and Z are all collinear. That's true. So we try to put P, N, and Z. And again, we don't know that N is the midpoint, so I'm not going to assume it is. And we try to put them all in a line like this, and it works out. It seems to work out okay until what? Until we put the numbers in, right? So let's try that. NZ is 8, so we say that this is 8. PN is 14. So that would make PZ, right, segment addition postulate 22, but it says PZ is only 6. So that's impossible, right? That's impossible. So we're going to back up and we're going to switch positions because PN looks to be, PN is the longest segment, so that has to be on the outside. So we're going to switch N and Z and see if that helps us. Okay, we're going to call this C and put N out here. And we're going to make a segment. And now, if we line up everything and we see that 8 and 6 and 14, that works pretty well. So you can see that I have it. Now, it's not drawn to scale, which happens a lot of times when you're forced to draw it yourself. So 8 is actually longer than 6. That's okay. It won't affect anything at all, right? Okay, so it says if M is the midpoint of PN, okay. So if M is the midpoint of PN, that's going to have, all right, you know what? Actually, I take it back. Because this problem is so complicated, I'm actually going to change the position of Z to make it a little more accurate. So I'm going to move Z here because that looks more like 6 and 8, right? That looks longer than 6. Maybe I made it too far to the left, but that's okay. All right. Okay, so it says M is the midpoint of PN, right? So here's 14. It's 14 all the way along this length, right? It's 14 all the way along. So if we go from this end here, the N side, and we went 7 back, that would put us right about here, right? So I'm going to have to change this 8 to be 7 and then put a 1 in between, see? Because this number always represents the closest distance between each point to the left and right of it. So because M is in the middle, that's 7, it's still 8 for NZ, and PM is still 7, or is 7, because that's the midpoint, but PZ is still 6, so I get a 6. And if I color-coded this maybe to help me a little bit, right? So that's 6, and then the green is 1, right? If I erase this. And we'll make this one blue. So the blue is 7. Okay? And that still preserves all of the given information from line 1, which is right over here. Okay? And there's one more. There's W is the midpoint of NZ. Okay, W is the midpoint of NZ. Now, if you remember, NZ is 8. So the blue and the yellow and the green here, excuse me, the blue and the green here are 8. And W is the midpoint of NZ, so that's 4 away. Okay, so I have to go 4 out here, which might be here. And then I have to change this 7 to be a 4 and a 3. Okay, let's still see if everything is true, right? First of all, is W the midpoint of NZ? Well, NZ is 8, and that's 4 and 4 on both sides, okay? Is M the midpoint of PN? Is M the midpoint of PN? PN is all the way across 14, so M is 7, 6 and 1, and 7 this way, 4 and 3. So you can see all of the given information still checks out, and I need to label this, of course, as W. Okay, so finally they want to know what is the length of MW. So this is easy. Once you've broken it up each time we did it, it's just staring in the face, it's equal to 3. All right, that's the distance between there and there. So if this is a complicated problem, just play it back a couple times to watch what I do. And remember, don't put a segment symbol over the top here. That's not right. Don't do that, right? That's not right. Oh, I didn't mean to delete the whole thing. Okay. All right, so watch that one a few times. That is a little complicated. All right, let's go to 3. So these are draw your own problems, right? So actually, it's not really important, but line segment AB and XY are congruent. It's not really important to draw because this is pretty obvious. Congruent means the measures are equal, okay? Measures are equal, means they're the same length, okay? And just for important discussion here, this symbol actually doesn't belong here. This is a mistake. I think we copied this problem. So that symbol doesn't belong there. It really should be written just AB equals, okay? You can't have that, so fix that on your sheets. And XY equals. Okay, now because they're congruent, because these segments have the same length, all we have to do is write an equation. Every time they ask you to solve for something, you'll see this in a lot of our different problems, you have to write an equation. An equation is how you solve for letters. If you don't have an equation, you can't solve for letters. So you have to ask yourself, what's equal or what adds up to something else? So when we get to the linear pairs, we're going to talk about in a little bit, sometimes things add to 180. Okay, they don't equal each other, they add to 180. But in either case, there's an equal sign and you can write an equation. But in this problem, it's very easy. It's just the two segments equal, the two segment lengths, equal each other. See, AB equals XY. So right below it, I substitute in the value for each. And we get this, okay? And then you know how to solve this. I'm going to go pretty quick because this shouldn't be new. Get the like terms together first. So I get 3n minus 8 equals 19. Add 8 to both sides. 3n equals 27. And real quick, I'll divide both sides by 3. N equals 9. Now that's not what the question is, right? So a lot of you are going to box this and go, that's it, that's the answer, but actually going to lose some points on the test because 9 has to be plugged in. They wanted to know what AB is. So AB is 5n minus 8. Remember, we did this earlier. 5n minus 8. So now I write, remember how to do this, 5, open parentheses, minus 8. Okay, and we're going to put this number in there, 5. N is 9. Okay, so finally AB equals 45 minus 8, which is 37. And now you put a box around it. Don't put a box around the other one, right? Because that's not the final answer. So don't put that box around this like I did, because that's not the final answer. Okay, this is the final answer. Okay, let's move on. Next page. Again, another drawing problem, so you have to draw this yourself. So ray PQ bisects angle HPJ. So first thing you do is draw this angle, then we'll draw a bisector, okay? Now, how wide or big your angle is doesn't matter because we really don't know, right? That's what we're solving for. Okay, HPJ, but you don't want to make it, you don't want to do this. So I'm going to show you something not to do. Don't make it like this, right? Don't do this. Don't make it a straight angle because that's making an assumption that isn't necessarily true. We don't know that. So don't put a straight angle here, 180 degree angle. Don't write that because we don't know. We don't know how big this is. It could be 120, it might be 60, we don't know. So we have to keep in mind that it's not drawn to scale. So don't make any assumptions about the size, okay? All right, so I drew the angle and it says though PQ, right? bisects the angle. So PQ is a ray. That's a ray symbol. So starting at P, you need something that goes halfway between the angles, splits it in two equal parts, right? And I'll draw that. So PQ, so that's ray, PQ, rays start at an endpoint. They go straight out through the point Q and off to infinity. And that cuts these two angles into two congruent angles. In other words, their measures are the same. Okay? Now they told us what these angles were. They said the measure of QPJ, that's the baby angle, right? We talked about two baby angles adding up to be a big angle, right? So measure of angle QPJ. QPJ is the angle right in there, okay? So that's going to equal 2x minus 9. And angle QPH is x plus 29. And they want to find, that's very important here, don't forget this, the measure, which we're supposed to write like this, measure of angle HPJ. Okay? HPJ is the big purple angle, not the two little baby green angles, so it's the big purple angle. But in order to get that, we have to solve this equation. So bisector means it creates two congruent or two equal angle measures, two equal angle measures. So I'm going to set these two angles, that angle and that angle, equal to each other. So x plus 29 equals 2x minus 9. I'm going to subtract x from both sides. I'm not going to show that work. That should be pretty standard for you. And I'm going to add 9 to both sides. Okay, and if I plug this back in to both of these angles, I really don't have to do it to both. I'll just put it into this one, right? So I'm going to put a 38 right in there, right? And when I add 38 and 29, I get 67 degrees. 67 degrees. And this one, without even testing it, although it's a good idea to test it, is 67 too, because they're congruent. They have the same measure, so I know both angles are 67 degrees. And if you try it, 38 times 2 is 76, and 76 minus 9 is 67. So it works, they're both 67 degrees, but this angle here is both of them added together, right? Two baby angles equal the bigger angle. Okay? So the angle itself is 134 degrees. That's the final answer. Okay, again, you have to find an equation. You have to write an equation. Okay, let's go to 5. If line A, B, and CD intersect at E, so I need to draw two lines, A, B. Why did I draw a diagonal? I didn't have to. I could have made it horizontal if I wanted to. Okay, and we'll color code these. CD, let's do CD. Intersects at E, so they're going to cross each other somewhere. Okay, again, I don't know for sure what angle they cross each other at, so I'm not going to be too concerned about my scale here. And of course, they do it at E. Okay, all right, we drew it. So now let's do this. The measure of AEC, that's this left angle here, is 5x minus 20. And the measure of angle BED is, which is over here, BED. You count from B through E to D. That means this angle here, okay? That angle there is x plus 52. Okay, now these angles here, that blue angle and this blue angle here, these two angles here are vertical angles, They're across from each other in the intersection of two lines. And what I told you to do is bring a highlighter into class and take all the straight lines like this, the ones across, and highlight them so you can see the angles across from each other are the same measure. So this problem's, again, a very easy 5x minus 20 equals x plus 52. We're going to add 20 to both sides. Actually, I'm going to subtract x from both sides first, sorry. And then I'm going to add 20 to both sides. Okay, and then divide both sides by 4. I'm going to do a quick long division just for good practice. 4 goes into 7 one time. Remainder of 3, bring down the 2, 8, right? So just in case you didn't know it off the top of your head, it's 18. Is that the final answer? No. What do we want to find? Always read and underline or circle what you're asking for. So they're asking us for, what is the measure of angle CEB? Okay, well, CEB is not even one of the angles we just worked on, right? CEB, I'm sorry, CEB. So CEB is this angle. It's right here. Okay, so what is that going to equal? Well, we know that the blue angle and the red angle together, right, this whole big angle here, that's not a great color. This whole angle here is a straight angle. We talked about Jason Kidd turning the nets around 180 degrees. That's 180 degrees. These are a linear pair. So anytime you have two vertical angles, they share a linear pair with this third angle. So let's plug our number in here. Let's plug our 32 that we got into this angle, see what we get, right? Plug 32 into here. So 32 plus 58 is 84 degrees. So this is 84 degrees. This angle has to be 180 minus 84 degrees because they both add up to 180, right? So 84 plus x, right? 84 plus x has to equal 180. That's what linear pairs, they're supplementary, okay? Linear pair. Okay, 180 minus 84 is 96 degrees. That's our final answer, okay? Okay, two vertical angles are complementary. Okay, so two vertical angles, that means the same measure. They have the same measure, so they're the same. And complementary means they add. Don't say they equal. That's wrong. Say add to, or their sum is equal to, but better to say add to 90 degrees. Okay, so I have two things that are the same measure that add to 90 degrees. Okay, well, that makes each one of them 45. I'm not going to go through the work. I think you get that. Okay, find the measure of each angle, so it's 45 degrees. Okay, new page. The measure of the greater of two supplementary angles is 5 times the measure of the smaller. What's the measure of the larger angle? So we covered this in class. You have to do a let statement. This is all out. The only thing that's not algebra 1 here is this, right? Is this. Okay, everything else is algebra 1. Let x equal the smaller number. Okay, or the smaller angle, actually. No, it's smaller. Yeah, smaller angle. Okay, and let the other one is what? 5 times the measure of the smaller. It's 5 times bigger than the smaller. Well, that's what 5x means. 5 times x, 5 times bigger. Okay, smaller angle measure. If you want to be fancy, and same thing here, right? Okay, so what does supplementary mean? Supplementary means they add to 180. So how are you going to get an equation out of this? They're not equal to each other like in the previous problems. So they add to 180. They, meaning the smaller angle, right? The smaller angle and the larger angle. They add to 180. So you're right. X, the smaller, plus 5x, the larger, add up to 180 degrees. That's what makes them supplementary. So 6x equals 180. And divide both sides by 6. X equals 30 degrees. What is the measure of the larger angle? Well, it's not 30 degrees, it's 5x, right? So you gotta use your let statement here. So it's 5 times 30, which equals 150 degrees. That's our final answer. Okay, 8. Again, we have a linear pair. We talked about this. Here's our straight line. There's our straight line, okay? This kind of splits the angles up. So you get an angle here, and you get an angle here. If together they make a straight line, if they're non-shared sides, see, they share the red side, and then each one has a purple side, right? So that one and that one. Okay, now it's blue, but you get the idea? So these are a linear pair, right? What do we know about linear pairs? Well, it's 8x and x plus 27. They're a linear pair. We know that linear pairs are supplementary. Supplementary means that one plus the other adds up to 180 degrees. Okay, so 8x plus x plus 27 equals 180 degrees. These are really degree symbols. So at like terms, okay, subtract 27 from both sides. Divide by 9. We'll do long division. 9 goes into 15 once. Remainder of 6. 7 times 9. Okay, so 17. And that's, of course, not the answer. That is what x is equal to. So we have to plug it back in here, okay, or in here. This one's a little easier, 27. So 17 plus 27, right? So 17 plus 27 equals 44 degrees. And we know the other one is supplementary, so that's easy. So it's going to be 136 degrees, okay? So here, this is very important. Name and find the measures of all four angles. Okay, so let's do the ones we know. Measure of CBD. So the measure of CBD equals 44 degrees, okay? The measure of the other one we found, ABD or DBA, but I'll do ABD, is equal to 136 degrees. Okay, now remember what we talked about with vertical angles a few minutes ago. So the two green ones here are vertical angles. They're across from each other in an X. And the two red ones here are vertical angles, okay? So very easy. The top angle here, angle CB. Actually, it looks like there's two C's there, so sorry about that. Or is that it? Yeah, this should have been, let's see, A, B, C, D, E. Let's call this one E. That's a typo. Which means I got to go back here. Sorry about that. So that's EBD. Okay, let's change that to be EBD. Okay, ABD still sounds the same. And then the other, so across from the 44, across from this one is this one. And they're both the same because they're vertical angles. So let's put a 44 degrees in there. So measure of angle CBA is 44 degrees. And the measure of angle CBE, sorry, this top angle, CBE, the measure angle CBE, is the same as the two green ones are the same, so it's 136. Okay, so whenever you have four angles formed by the intersection of two lines, you're always going to get this double pattern here. Okay, just so your answers will be a little different than mine. I apologize because this letter should have been E, or maybe it was and I couldn't see it when I wrote over it, but just change your letter to match mine and then you'll get the same answer. Okay. All right, number 9. We have a line. It's piercing the plane right here. There's the dotted line to tell us it's behind the plane. We have another line, DB, over here. True or false, point A lies on plane FCP. That's false. Okay, it's false because this point is above. How do we know it's above? Because this line, AE, is going through. It's piercing the plane. That's what this dotted line tells me here. So I know A is above and not on. Points D, C, B, and A are coplanar. So coplanar doesn't mean they're on the blue plane, right? Coplanar just means can be drawn on a plane. On a single plane, right? Can be drawn on a plane. Doesn't have to be the one that's drawn. So if you remember in class, we took the sheet of paper and we bent it. Not bent it, of course, but we twisted it or turned it. And we were able to hit various different points. So DCB are all collinear. Collinear. Okay. So that means they're all on the same line. You can have an infinite number of planes, right, going through that. So you can have a nice vertical plane here. Nice vertical plane, dotted lines, it's behind, right? Nice vertical plane here. And it would pass right through A, right through A. It's because you can have any collinear points. So you could have 100 of them along here. And we could turn this plane really any direction we want to, right? We could turn it like this, any direction we want to hit any additional point. So A is the additional point here. So D, C, B, if I put another point here, W, you could have all of these collinear points and one other point, any one other point, and they would be coplanar. They would be coplanar. Okay, points A, B, and E are coplanar. I don't even need the diagram for this. Don't even need the diagram for this, okay? A, B, and E are coplanar because any 3 points, and that's going to be a question too on the test, right? We talked about this. Any 3 points. Doesn't matter where they are, any 3 points. Okay, segment FC lies on plane FCB, right? Well, C is on the plane, F is on the plane, that's the intersection point, so the entire segment lies on the plane. That's true. AB intersects plane FCB at B. So AB, which is not drawn, but it exists, right? So this line AB from here to here, does that intersect the plane? And the answer is yes, actually. It doesn't go through it, which can confuse students a lot of times. but it hits a point on the plane. It shares a point with the plane, so it definitely does intersect it, and it does intersect it at B. And finally, segment AE and DB intersect. So segment AE, that's this red one up here, and segment DB is the one back here. Do they intersect? Okay, it looks like they intersect, but they don't, because that's where FC is coming from, right? So F is more in front of C, so this red line is in front of the green line. If we were to turn it sideways, it would look like this, right? If we were to turn it sideways, green would be coming out of the blackboard like this, see? That's coming out of the blackboard right towards you, right? Imagine this is coming right at you and into the blackboard or into the smartboard. So we call these skew lines, right? These are called skew lines. This is false. Okay. All right. Page 4. Okay, some of these are repeats, so we're going to go really quick through these. Sometimes, always, and never. 3 points are always coplanar. We just talked about that. 2 opposite rays always form a line. That's true. So opposite rays have a shared endpoint, and they go in exact opposite directions. So that's an always also. An angle can sometimes be named by 2 points. That's a never. It can be named by a number, like angle 1, by a single letter, though we don't do that one a lot, not till later, or by 3 letters, but never by 2 letters. So this is never. A ray has 2 endpoints, never. You know by definition, a ray has 1 endpoint. Rays AB and AC are the same ray. So if you start at A and go through some point B, right? And if I put point C here, then they could be. But, of course, I could move point C. I can move point C to here, and now they'd be 2 separate rays. Okay, so unless they said A, B, and C were collinear, that would be a different story. So this is a sometimes. The name AD, segment AD equaling segment CB, is never true. You cannot name it. You'd have to put an M here if you wanted to do that. See, that would be always true, right? But they didn't, so we're not going to keep that there. Okay, 3 points. This is a repeat of G, so you can kind of ignore this one. It's just the same as A, right? Same as A. 3 points are what collinear? Well, we know 2 points are collinear, A and B, but A, B, and C are not collinear, so that's an example of it not. But of course, we could have a point D here, and those 3 points could be collinear, right? So this is a sometimes. Of course, 2 points are always collinear, but they asked us about 3. Okay, 2 lines in 3D that don't intersect are what? Sometimes parallel. We just covered that, right? So you could have a line. If you think about the side of a box is the best example, and you saw this on the other sheet, right? Think about a 3D box, right? This line here going up the back, right there. It's not a great line. And this line going here in the front, saying that line across the front here. If you put these 2 lines or a big piece of string on a box like this, even though it looks like in 2D that they're going to cross each other, they're not, right? Because that green is in the background. So 2 lines that don't intersect are sometimes parallel, because of course those aren't parallel, those are skew, right? But sometimes they're parallel, as you know, like train tracks, right? So if you made train tracks, the rails themselves are parallel. Okay, 3 planes meet at a point. So that happens in our room, right? That happens in the room if you look at the corner of the room. Like this, right? This is from the outside of the room, and there's our roof on the top. You can see that all 3 of these meet here, right? There's the 3 planes, the front of the room, the side of the room, and the top of the room all meet at a point. But planes can kind of pinwheel. We talked about this in class, like a book, like pages in a book, right? So here's pages in a book. And maybe another page like this, okay? There's a page. There's a page. There's a page, right? So they all meet at this line. Now remember, this is a line even though it looks like a segment, because planes don't end. That's very important. So they actually meet at a line, not a segment. So sometimes is the answer to that problem, sometimes. Okay, find all the missing angles. We're going to go pretty quick here. This is 50. That's a vertical angle to this angle. Notice, again, I take my highlighter, bring highlighters in for the quiz, right? And I highlight this, and I highlight this. Okay, there's my 2 lines, so I know that across from each other, they're equal in measure. And then I know that two angles that make up a straight line, so here's a straight line right here, see, are supplementary. So 180 minus 50 is 130. Okay, this is 90 here. This is 90 degrees. That's a 90-degree symbol. Okay, and there's a couple things you can do here, right? Of course, 50 plus this angle plus 90, even though they're not a linear pair, they are kind of what we call slang linear angles. Those three have to add up to 180. Okay, there's another way to do it too, though. This angle here, this 130-degree angle here, is a vertical angle, believe it or not, with these two angles. Of course, we don't say that. It's just with the big angle. So we would say X, A, Y. That angle is vertical with W, A, U. So you know that this has to add up to 130. So what would make 130? 40 degrees. Okay, that's one way to do it. You could also do what I did earlier, just say 90 plus blank plus 50 equals 180, and that would also make 40. So there's a lot of different ways to fill in the missing angles. Okay, that's it. Good luck on the quiz.